Welcome to an example in which we're looking at which of these tables could represent a linear function. Okay, so let's talk about a linear function and what it is. Notice over here on this first one that this number goes up by 10 from 11 to 21. 11 to 21 goes up by 10, and then it goes up. Oh, actually, let me come back to that one. That one's tricky. So notice over here, this one goes up by 10 from -2 to 8, and then it goes up by 10 again, and then it goes up by 10 again. So it's always going up by the same amount. It's going up by the same amount. So it has a fixed slope, meaning it is linear. That's what linear means, right? Because notice when x goes up by 5, y, f of x is y, goes up by 10. So y over x, slope, rise over run. That's what slope equals. Rise over run. So y goes up by 10 every time x goes up by 5, meaning the slope is 2. Right? This is always going up by 5. See that? And the y values are always going up by 10 at every jump. 10, 10, 10. So that's a slope of 2, one steady slope of 2, and it is linear. So we check that one. That one's linear. Now the next one is, or I'm going to jump to this one. This one's going up by, or down by 25, I think. Down by 25. And down by 25. Yeah, every time. That's the y values. And every time x is going up by 5, up by 5, up by 5. So the slope is a steady rise over run, y over x. The change in y is minus 25. The change in x is 5. It's a steady minus 5. That's linear. One fixed slope. That's what a linear function is. It has a line, if you graph it, if you graph something, and a line for this one, in fact, let me do this. This one, as to graph this one, this one is a -5 slope. So it's going to go down like this, -5 slope, whereas this one up here is a +2 slope going up. Okay, so those two are linear. Now, this one right here is not. See how this goes up by what, 25, and then the next one goes up by, I don't know what, 75, and then even more. It's changing, right? This one goes up by, I don't know, 125. So it's changing. So it's not linear. So that one is not linear. Cross that one out. Now, the trickiest one of them all is this top one, because at first it looks like, oh, it goes up by 10, and then all of a sudden it goes 20, and then only up by 10. So it looks like, oh, it's not the same, but careful. See how they messed with the x values? This goes up by 5, and then that one went up by 10, and then that one went up by 5. So that jump, so it's 10 over 5, rise over run, slope, y over x is y, is 10 over 5, right? When you compare those two numbers, see how it's 10 and 5. The next, but the next one changes. Well, it's 20 over 10. And then it's back to 10 over 5 again. Those are the same thing. Those are all steady too. So that one is linear. That one actually is linear. That's the trickiest one. Let me check that one. So those three are linear. Did you see my answers there? So check it out. So that one's linear, that one's linear, and that one's linear. Those three are all linear. The trickiest one to see was there this one, because at first you go, oh no, it's 10, then 20, then 10, so that doesn't work. But that's because the x's weren't consistent. See how they messed with the x's? All the other ones were 0, 5, 10, 15, 0, 5, 10, 15, 0, 5, 10, 15. They all went up by 5. But here they tricked us. 5 goes up to 10, goes up by 5, then 10, and then only up by 5 again. So in other words, it's always rising at the same rate, the same slope. The rise over the run, the y over the x is 10 over 5, right? 10 over 5, and then 20 over 10. And then back to 10 over 5. Well, so the 10 over 5, 10 divided by 5 is 2, like 20 divided by 10 is 2. It's 2 either way. It's a steady linear slope. So that's what a linear function is. It has the same rise over run, the same change in y, a steady change in y over change in x, a steady slope. So that one is linear. So there we go. 3 of them are linear.